EDX Mechanics 1, Work Energy and Power 2, Power, Motion on Inclined Planes. The diagram represents a crate being pulled up a rough slope by a winch. If the winch develops 6 kilowatts of power and the crate takes 50 seconds to move at a constant speed 25 meters up the slope, what is the work done by the pulling force Ft in this time? So we're looking for the work done by the pulling force. We know that the work done by Ft is power times time. So that's just the rearranged power formula. The power being generated by the winch is 6,000 watts, and the time to pull it up the slope is 50 seconds. So the work done by the winch is 300,000 joules, or if you prefer, 300 kilojoules. So we know work done is power times time, gives us the required answer. If the winch develops a power of 6 kilowatts and the crate takes 50 seconds to move at a constant speed, 25 meters up the slope, what is the resistance to motion of the crate up the slope? Well, I'm going to show you two methods for this. The first method is based on the idea of work and energy that we've been looking at. So first thing to consider is the work done by the winch. And we know that the work done by the winch has got to raise the crate up the hill, so it's got to give it potential energy, and it's got to also overcome the resistance force. So if we start off by looking at the work done by the winch against gravity, so that's going to be the potential energy gain, so that's mg8, so this will be 1600 times 9.8 times 25 sine 35. And now if we look at the work done by the winch against friction, that's the force, which is Fr, times the distance, which is 25 meters. So we now know that the work done by the winch is equal to the work done against gravity and the work done against friction. So the work done by the winch can be written as 1600 times 9.8 times 25 sine 35 degrees, and the work done against friction is 25 Fr, and that's the work done by the winch. And we know that the work done by the winch, we already know, is 300,000 joules of work. And if we solve that, we get the resistive force Fr is 3006 newtons. So just to reiterate, if we think about the work done by the winch against resistance and against the weight, the work done against the weight is mgh, the work done against the resistive force is 25 times Fr, and the total work done by the winch must equal the work done against the two forces. Therefore we get our equation which we can solve for Fr. Just to show that this work we've been doing on power, work and energy ties in with earlier mechanics ideas, I'm just going to look at this question again in a slightly different way and see if we get the same answer. We know that this crate is being pulled up at constant speed. So that tells me that the acceleration must be 0. It's moving at a constant speed. So if we think about the work done by the winch again, work done by the winch equals the force produced by the winch times the distance. So we know that the work done by the winch is force times distance. We know the work done already is 300,000 joules. Ft we're looking for, and we know the distance is 25 meters. So we now know that the force produced by the winch is 12,000 newtons of pulling force. We know the acceleration is 0. We know that all the forces are constant. So if I put the angle of 35 degrees in there, I can now do Newton's second law up the slope. So pulling up the slope is Ft, that's 12,000 newtons. Pulling down the slope is Fr, so that's negative Fr. Also pulling down the slope is 1,600 G sine 35. That's pulling down the slope, so that must be a negative force. And that total force must be 0 because the acceleration is 0. And if we solve this for Fr, we'll get the resistive force is again 3,006 newtons. So we can see consistency between this 0 acceleration equilibrium of forces method and the previous use of power and work done. And that brings us to the end of this section on work, energy and power 2.